Okay, today we're going to finish up with this multiplying radical expressions. And when you look at multiplying radical expressions, I'm hoping that they feel a little bit familiar to you, or at least they appear to look an awful lot like FOIL problems, because we should really treat them as FOIL problems. So when we look at this, 3 plus root 5 times 3 minus root 5 is a binomial times a binomial. So we have two choices. We can either use old-fashioned FOIL arrows, so you can multiply firsts, outers, inners, and lasts. Or you can use the box method. Either one is perfectly okay with me. They all end up with you doing 4 multiplications. It's just about preference. I think those of you who are really comfortable with this box might want to try moving towards the more traditional version, because I'm kind of the only teacher that uses the box method. Nobody's going to complain about it, but you might find that you want to start making a more traditional approach to your work. You don't have to. So if you're using the box method, you're going to align it like this. And you're simply going to multiply. 3 times 3, well, that's pretty easy. That's a 9. Right? And if you do it traditional FOIL, you're going to write your 9 over here. So then we're going to do 3 times negative root 5. So 3 times negative root 5. Whole numbers or things that are outside a radical always go outside, and anything that's inside a radical can get multiplied together. So 3 times negative 1 would give me negative 3, and root 5, and there's nothing inside the radical, so just a root 5. So negative 3 root 5, or minus 3 root 5, or plus negative 3 root 5. Then we do our inners, and that looks like root 5 times 3, or 3 times root 5. We end up with plus or positive 3 times 1. There's really an invisible 1 out here. So 3 times the square root of 5, because there's no radical portion. You could write it, traditional method, you write it plus 3 root 5. And the last multiplication is to do root 5 times root 5, or rather negative root 5 times root 5. So a negative 1 times a positive 1 gives you a negative 1. And square root of 5 times square root of 5. That's going to give you the square root of 25. So minus the square root of 25. Well, wait a second. The square root of 25, don't we know that? Remember, the radicals can only be considered like variables once they're simplified. So now we need to simplify any radicals that we can and combine like terms if we can. So we should be seeing two things. Let's do them one at a time. Let's start with, I'm just going to keep this 9 minus 3 root 5 plus 3 root 5. I'm just going to keep that, although I think some of you are seeing those as like terms. Minus the square root of 25, which is 5. Now we can combine like terms. We'll do our constants first. So positive 9 minus 5 is a 4. And then we do our radical portion. So negative 3 root 5 plus positive 3 root 5. Remember, you should think x and x, right? Negative 3x plus 3x. So they would add to 0. So that my final answer to this problem is just 4. Would you please give the next problem, actually the next 2 problems, I think you can give those 2 a try. Come back, check your work, and then we'll do this bottom problem together. And I think we'll do that 6th problem all the way together, the one that I have green on. So pause the video and do these 2. All right, welcome back. And I hope you did these 2 problems, and whether you used the box method or you used traditional FOIL method, in either of these, I hope you noticed that this time when you did them, that you did not have like terms, nor did you have any radicals that would simplify. So instead of ending up with a constant, you ended up with a polynomial. It actually has 4 terms for both the first the blue problem and the black problem. They each have 4 terms to their work. So sometimes that happens as well, that there's nothing more you can do other than multiply. All right, let's do this first problem together and the fourth problem together, and then I'll leave you that middle 5th problem on your own. So first thing we're going to look at is the fact that we have a quantity squared. We can in fact use our shortcuts, but most of us aren't quite as comfortable as I'd like you to be with those shortcuts. So we should be thinking that that means we should take 7 plus the square root of 2 times 7 plus the square root of 2. And now we can apply our FOIL method. Again, you can use your box method or your traditional. Since most of your teachers next year are going to use traditional, I'm going to start sliding into that method so that you're more comfortable seeing it. But again, it never matters. So first, outers, inners, and lasts to make sure we get all 4 multiplications. 7 times 7 is 49. 7 times the square root of 2, outsides times outsides, insides times insides. So 7 times 1, and there's only a square root 2. Then we'll do inners, root 2 times 7. Again, 7 times the square root of 2. And last but not least, root 2 times root 2. Positive times a positive 1, so positive 1. And 2 times 2 would be the square root of 4. And now we can simplify. You can do this in 1 step, in 2 steps, however much it takes you. I'm going to show my work, since it's my notes, I'm going to show it in a couple of steps. The first thing I'm going to do is combine like terms here and simplify, because the square root of 4 is 2. So 49 plus, those radicals are simplified, so 7x plus 7x would give me 14x, which we're really considering to be root 2, right? Plus the square root of 4, which is 2. Last piece is 1 more combined like terms. Those are my constant terms. 49 plus 2 is 51 plus 14 root 2. Why don't we take a look at this 6th problem together? Notice that you have I've already drawn in those old-fashioned arrows for you. Remember, I've been saying outsides times outsides and insides times insides. So we're going to do 2 root 3 times the square root of 3. So 2 times 1 would be 2, and 3 times 3 is on the inside of the radical, so that's the square root of 9. Let's do outers. That's 2 root 3 times 6 root 5. 2 times 6, that's 12. And inside the radical, we would have 3 times 5. That's 15. Inners, 4 root 5 times square root 3. 4 times 1. And on the inside of the radicals, 5 times 3. And then we need to do our last. 4 root 5 times 6 root 5. 4 times 6 is 24. And square root 5 times square root 5. So square root of 25.